Okay, hey everybody, thanks for joining us on CodeChat. My name is Jeremy Foster. You can find me online at codefoster.com or on Twitter at codefoster. On this edition of CodeChat, as you can tell, we're not in the studio today. We are live on location at Building 20 on the Microsoft campus, and I'm here with Ahmed. Do I say your last name Daoud?
Daoud.
Daoud, okay.
It's Arabic for David, actually.
Oh, awesome. Yeah. Ahmed Daoud. Ahmed, what are you doing here? What are we doing in Building 20?
So I've been here accidentally.
That was a preview of things to come.
I've been here since August 11 as part of the Microsoft Ventures Accelerator here in Seattle, or Redmond technically.
Yeah.
So there were 127 startup companies that applied to this program with Microsoft Ventures, and it's a themed accelerator, startup accelerator.
Okay. And what's the theme?
The theme is IoT. So
Internet of Things. It's fun.
The buzzword that means everything and nothing all at once.
It's very popular to say these days, though.
So 127 applicants applied, and we were very fortunate to be one of the 10 who were selected.
Excellent.
In the final pick. So since then, we've been here. Every company has, one person traditionally or more that are stationed out here primarily throughout the duration of the program.
Okay.
Playdabase, which is the company I'm representing, has been committed to having one person uprooted from our home base in Minneapolis and being here, and that has been me.
That's you.
So I've been here for the duration of the program so far, and we continue on until mid-December. So I still have as much to go as I've been here.
And you've got a life and family and everything back in Minneapolis that you...
Luckily not a family just yet, because I think that would have been a really hard sell.
Yeah.
But yeah, I do have my social networks there, my life and everything. But I got the opportunity to pack up and leave and work out of Microsoft and work with Microsoft engineers on something that I'm passionate about. I've been working on for over a year and a half now. So it was, it gave me pause, but it really was a no-brainer when it came to it.
Yeah. Now, the crowd is mostly developers, just so you know. Most of the folks that tune into CodeChat are people that want to write code, and these days they want to hack on hardware and do all kinds of fun gadgety things. Awesome. And that's excellent. And we've got gadgets all around us here.
Yeah.
And your company, you said that your company is Playdabase, right?
Yes.
And you've got a product here. Can you tell us a bit about it?
Yeah. So our product is Reemo, and let me say that I'm very excited to see the emergence of developers wanting to play with hardware.
Yeah.
As someone who's an electrical engineer by trade, who's very much enjoyed playing around with software, it's nice to see that that's happening in both directions.
Yeah.
So let me give you a quick walkthrough of what we have here. I gestured again. But this is a prototype of our wristband.
Make sure you give us a big overview first, too, of like what is it that Reemo does.
Yeah. I forgot that most of you guys don't know what our product is. We make Reemo, which is a wristband that allows you to control connected devices, IoT devices, and home automation devices in the general sense through gesture alone, through wrist control gesture alone. So that means it makes home automation IoT accessible to people who are not technically savvy and don't want to sit around and tinker with settings or scroll through a long list of devices on their phone to turn off the light that's right next to them. You can point at it and gesture to control it to turn it off, or point at your TV and turn up the volume, point at your blinds and raise them. Whatever device in your home that's connected, you can control it through our wristband, one way or another.
Who do you think is going to be using this Reemo device? What's the...
We have use cases coming at us faster than we are actually able to hypothesize them as a company, because people are seeing this and being very excited about, well, I could use this for this. I had someone the other day come up and say, well, this would be great for my dog. I said, well, that's a new one. I haven't thought of that one. But if they could be, she was saying if they could be trained to do a gesture with it. So there's just a lot of use cases coming at us. We think there's a lot of interest in niche applications such as the healthcare space, the aging in place, people who are aging and want to stay in their home, want to stay active there, people people with disabilities, in childcare situations, but mostly in just the modern family setting where you have a family. There's several people in there. A lot of people are active. The parents are active. They're very busy. They have 2.5 kids.
Yeah.
They're getting ready in the morning, cooking and trying to control your home at the same time may not always be the easiest thing. So just for that general setting where you live in a home and you want that home to become more accessible and useful to you. If you are aging or you have a disability, even more so a quality of life improvement.
Yeah.
But I think it's very widely applicable to any home setting.
Yeah.
Yeah.
Okay, so it's basically going to be replacing, like you said, the need for doing any scroll lists, configuration, like learning how some computer system works. Basically, it's just going to be on my arm.
Which I love is cracked, and that makes it more challenging to scroll through and find lamp number 3 and turn that off. If I have 10 lights in my home, unless I've taken the time to painstakingly name all of them, and then furthermore remembered what each of these names referred to, this is not a very scalable
and all the more difficult for my grandma on her flip phone.
Exactly.
Yeah.
Exactly. That makes it completely inaccessible. So, home automation is a great space, but it's very young and it hasn't matured as far as how it interfaces with the user.
Okay.
Because we've been building IoT as an IoT community, as much as I hate to use that term, but it's inevitable at this point, for a few years now, maybe 3 or 4 years, and even longer by some measures. But we haven't quite thought through how do we integrate the user into the Internet of Things. How do we make the user another connected device, so to speak, or another connected entity, so that the connection and the interface of these devices is more fluid and more direct and more organic, as opposed to being very mechanical and disjointed. If I'm having a conversation with you right now and we're having a good conversation, if I have to say, "Excuse me, Jeremy, give me a second while I turn off this light," and then I have to take away from my life, from what I'm doing, disengage from my conversation to control a light that's right there, that's not a great use case.
It's not a fluid interaction.
It's not a fluid interaction. It's not a fluid interface. I saw a demonstration at the CEDIA conference in Denver last month by a company that's very, very prominent, and I really admire, and they're very prominent in the space of creating a comfortable home. And they had entire setups allowing you to set up different scenes for your home. So they had this video showing a guy who sits down with his family and sets his home to a dinner scene.
Okay.
But there's this beautiful setting of this beautiful family sitting down having a meal, and then he has to look away from his family to his phone to set the dinner scene.
Yeah.
And I felt that was very mechanical and really disrupted the flow of that beautiful evening. So for us to be able to connect with our devices directly and communicate with them directly, integrating into that larger connected scheme, I think is the next evolution of how we as humans decide to interface with devices.
Okay.
The same way we invented a mouse to control a computer in a more fluid interface, I feel like this is the mouse for connected things.
I hope your device gets as popular as the mouse,
Well,
because that's doing pretty well still.
I hope so too, yeah. That and blue jeans.
Yeah, right. What kind of gadgets do we have here?
So here to showcase our interoperability with different devices, we have a Yale lock that we're controlling.
Okay.
We have a smart plug right here that's made by a company called Centralite.
Okay.
For a company called iControl, which I have their module here, and this is the hub and the display for their home automation system.
Okay.
And they white label for Comcast, Cox, Time Warner, Rogers, ADT, all of these companies. The backbone infrastructure and all of the devices are white labeled by iControl.
Okay.
We are partnered with iControl currently, so we are compatible with 2.4 million homes plus out of the box.
All right.
So yeah, these are the devices, the third-party devices.
And this is going to be an actor in the demo today, right?
Yes. Yeah.
Got this lamp all rigged up.
Plugged in directly to.
Oh, that's going into the plug device. Okay. Excellent.
So these are the third-party devices that we have. Our devices, this is our hub, so it's a nice grabbable form factor, even though you shouldn't have to hold it and carry it around much. It's really supposed to be stationary, but it has an Ethernet port, so you can connect directly to your home LAN network as well as a Wi-Fi connection. And takes a standard 5 volt or 12 volt DC adapter input. We have different stages, and this is really cool. We have different stages of our prototypes here. So this is the one that I'm going to be using today, and this is a giant honking board inside.
So the final product's not going to be this large, right?
Well, it will be for a limited edition. if you're really interested in
if you want to combine your gesturing with exercise.
Yes. Yep. The next iteration is this size, so you can see that it's significantly smaller. The curvature is more palatable. It's easier to wear. While this uses Velcro, this one uses a magnetic attachment.
Oh, that's slick.
Nifty. Yeah. And this is the board that goes inside it. So we went from this board here, which is gigantic, to one that is about a quarter of the size. Not only maintaining all of the components, but adding a few features. As you can see, there's an antenna here. This is for NFC. So I will not disclose all the features that will come from that, but you can speculate as you please.
Of course.
There's also a haptic feedback motor. So it's been a design consideration for us from the get-go to not have any tricky aspects to this, much to the chagrin of many of my engineers.
What are you talking about, tricky aspects?
We didn't want it to light up.
Okay.
We didn't want to have any LEDs on it.
Okay.
We didn't want it to have any visible or audible feedback.
All right.
We wanted it to be discreet, so
Yeah.
that it just disappears into your body, and to the user, there happens at some point a paradigm shift and a shift in how they view their electronics as not these things that they have to interface with, but these things that their body controls.
Yeah.
So the more this disappeared into their body, the better it served that purpose.
Mm-hmm.
So the only way we could think of to provide some sort of feedback to say, well, this worked, this didn't work, your gesture was recognized, was to have a haptic feedback motor in it. So that's why we added that. We actually go through these very extensive thought exercises as to what vibration sequence and what waveform is appropriate for what sort of feedback.
Yeah.
We try to obsess in every single way about the user experience for our device. And we take a lot of pride in it. So going along the user experience aspect, so this is the receiver that I'm using today to receive the signal from my gesturing. So there's two aspects to the gesture. One gesture is you point at a device, which in effect you're pointing at a receiver placed next to or overlaid on that device to control that device. And then the second is then you gesture, and you don't need to maintain line of sight at that point to control the device. So the selection, which happens through a line of sight technology, and then the control, which happens through a non-line of sight wireless technology. So you can move around and still control the device that you just pointed at.
And there's probably some reasoning for that, right? If I'm in a certain room and I'm going to gesture toward a device in the room, maybe a lamp, it's good that it's not going to be confused with the lamps in the other room.
Exactly. With
something that's not a signal that's not line of sight.
And we found that that's kind of the more natural way that people wanted to interact with their technology, because if I were injured right now and I couldn't get over to turn off that light next to you, I would say, Jeremy, would you kindly turn off that light? That's
You'd
what I
point
would do
to it. Yeah.
naturally. I point at it to reference it in my physical space.
Yeah.
So the term I use a lot is I see, therefore I can. If you can see it, you can control it. If it's within your vicinity, control it. And most of the time, people want to control things that are directly around them.
Yeah, right.
So this is the current prototype that I'm using of the receiver, or the previous prototype. The new prototype, we've gone from this size to this size.
We're getting a lot smaller here.
And no electrical tape too on the new one.
So that's something that might be attached to my lamp, or maybe the wall next to my lamp?
Yes, so you'll see here, this one has double-sided sticky tape.
Okay.
So you would attach it here.
Okay.
And you're effectively pointing at the lamp and you're controlling it.
Okay.
I don't have the
it's durable as
firmware
well.
or the tape are not quite figured out yet. But this is the guts of this receiver. So we received these.
Can I ask how that's powered?
Coin cell battery.
Okay, and so that'll last a while. So it's nice I don't have to run an extra cord to my lamp. Powered by the wall.
Yeah, absolutely not. This should last about 6 months. We're trying to get it up there.
Mm-hmm.
We can do 3 months fairly easily.
Yeah.
We're trying to push it to 6 months, and that's just cycling power states, what stays awake and what falls asleep.
Yeah, right.
So there's a lot in embedded development, which is the world that I come from, in how do you manage these power states? How do you keep a device functional, yet still keep it consuming the lowest amount of power?
Right.
Even if you have to say, well, if I'm doing this task, which isn't very computationally expensive, let me clock down my processor down to a quarter of its processing speed, and now it's running at 4 hertz as opposed to 16 hertz, or megahertz, and that saves me a lot of power.
That's some interesting optimizations.
So you even duty cycle your clock speed sometimes, just based on, well, I'm anticipating this event to happen at some interval, so I'm not going to stay on and watch for it the whole time. I'm going to wake up and look for it every now and then.
I see.
So there's a lot of fantastic things you can do with that. Now you have microcontrollers such as the the ARM M0 cores, and we're using the ST version of that. The M0 Plus, actually, which is the lower power of the M0s. And they have really interesting ways to control power states. You can really go into deep sleeps and leave one thing alive, which is what we do. We put the whole system on deep sleep. We leave one thing alive to just watch for that signal.
Okay.
And it wakes everything up.
All right. So does it work right now? Can we actually see it work?
Yeah.
All right.
You'll have to settle for watching the older prototype work.
It's okay.
But that'll have to do for now. I think you guys are developers and you understand the prototyping.
Okay, so you just did a gesture, like you pointed and then you twisted your arm.
And now I twisted my arm for a control gesture.
All right, and here we've got our door. Oh, things are happening all around us.
So I'm going to sleep now.
Okay.
I armed my home. So I locked the locks and turned off the lights. And there's a thermostat here that doesn't do the greatest job of displaying because it actually doesn't adjust the display when it adjusts the temperature. But this is also a wireless Zigbee thermostat that will adjust the temperature as well when I'm going to bed.
Okay, so multiple things happened at the same time. Does that mean that I only need one of these gadgets to detect that motion and it can control multiple things?
So exactly. I pointed at just one, and this was my security system receiver. And it's connected to, or pointed to, it's actually just a pointer in software that says this receiver's reference points to a specific device or a specific set of controls. So this is pointing to my security system.
Okay, so I might have a receiver on this lamp, so I could address it individually and just turn the lamp off, or I can address my security system, and it might also turn the lamp off.
Exactly.
Okay.
Yep. So you can do really cool combinations. You can even do a many-to-many or a one-to-many.
Okay.
If you want, so you can have multiple receivers for that same lamp. Just that lamp.
I see.
So choose, and then control it from anywhere in your home.
Oh, I see.
So the idea is, the primary use case is, we really want to encourage people getting in the habit of placing these on or immediately next to the thing they want to control.
Okay.
For the most basic use case, so their minds get trained to point at devices and gesture to control them. But there's a lot of interesting, cool things that I think developers, more so than the majority of people, would be interested in doing, creating all these custom setups in your homes or in your environments, in your labs. So you can also do a many-to-one, so you can have one of these receivers point to multiple lamps or multiple devices to control them at once. The nuance in control you can have then is limited, because let's say I put a lamp in connection with a lighting system. So you can do a lot more with the lighting system that dims and brightens. If you have just an on-off lamp, you're not going to be able to do all the controls if you link them together. But there's still
how fine or how detailed are the gesture recognition capability? So in other words, I saw you did this gesture and then you turned your arm. It's obviously not going to get anything with the fingers. It's just detecting the motion of the arm, right?
So we felt that allows people more access, a wider range of people access to the technology. If we rely on fine motor controls, then that rules out a lot of people who have disabilities, a lot of people who have motion challenges.
There we go.
Just gestured on it again, so I'm going to take this off. But a lot of people with different physical conditions may not be able to use a device, may not find it accessible if it relies on fine motor controls.
Yeah.
There are devices that are attached to your ring finger,
I see.
things of that nature. Those don't scale really well with people varying different degrees of ability.
Okay.
Also relying on muscular control in general. There are armbands that do that. That also tends to degrade quickly with people who are aging or people with disability.
Do you know, and are you allowed to talk about when you guys speculate we might have a product on the market?
Yes, I am allowed to talk about that since I get to set that and then get held to it. But we will have a product on the market in Q2, early Q2, hopefully, if certification regulation testing goes well.
Okay.
And the form factor should approach something like
look at this. Look at that. That's dramatically different.
This is a prototype of the form factor. This is not functional, unlike these other two, which are functional prototypes.
Mm-hmm.
This one, we have not yet scaled the electronics down to fit this form factor, but we've been working on different features of the form factor. As you can see, there are magnets here.
Yeah.
And that's how it attaches, so you can have different sizes.
Okay.
So we're also doing a lot of R&D on just the aesthetics and the form factor and the fit. So that will be Q2 of next year.
It's kind of fun. A lot of modern startups are software only, but something like this is, you're having to bridge that divide between software and hardware and do it both, right?
We are very hardware intensive, but we're also realizing a very strong need to keep adding. As we continue to refine and iron out a lot of our hardware and firmware challenges, we're starting to realize more and more need for more software focus on our end. So we've been working on our Azure cloud integration. Right now, when I gesture, this goes up to our Azure cloud. There's a Nitrogen server in there, and Nitrogen is something that a lot of even Microsoft people haven't heard about, but it's a new thing that came out of TED recently, the Technical Evangelism Development.
Yeah, and it's a JavaScript library, right?
Yep. It's written on JSON primarily, but it has a lot of different components, including an event manager and different ingestion aspects to take in the data streams from our device, churn them, and then we have a piece in there called the iControl Manager that was recently developed in conjunction with some of the Microsoft engineers that talks to iControl, the system that we're partnered with. We've also been working on AllJoyn compatibility. AllJoyn is a new IoT connected device standard developed by Qualcomm that Microsoft's been increasingly more invested in.
Okay.
And for a good reason. It really is kind of the most scalable IoT platform that I've seen to date, and the one that's gained the most traction. It's wonderful for developers because it's the only open source IoT platform right now, which really explains why it's gaining the traction that it's gaining. It's moving as quickly as it is, and it's getting a lot of attention from big players like LG. So all of the new LG smart TVs will be AllJoyn compatible.
Yeah.
Which means if I have an AllJoyn device, such as if I make my Reemo hub AllJoyn compatible, which we're working on currently, I can have any status messages displayed from Reemo on that LG TV. Because they all understand each other. The TV says, I have a display if you'd like to use it.
Yeah.
And it can broadcast that on the local network, and my device can come on and say, hey, I'd like to find a device with a display. And it finds that LG TV, and then it uses its display for notifications.
Well, that could be fun.
So yeah, and you can do that not just for display, but more interestingly for control. So the TV will say, well, I have volume control and channel control and brightness control, and I'm exposing those on the network. Does anybody want to control any of these things? Same with temperature control. So
that's interesting.
Yeah.
Hey, so tell me this: a lot of developers have the skills, and of course, they all have the resources to get the software that's necessary to write whatever package they need for some custom project. A lot of developers have at least access to a 3D printer so they can make these cases and these things.
Yeah.
Going to sites like Thingiverse or whatever to just print, or just creating their own using SketchUp or using whatever. Their own cases and things, but as far as the hardware goes, I feel like we're still relegated to ordering packaged hardware, little Arduino devices and Galileo devices, and one that I'm playing with is called the Tessel, which is kind of fun. It just runs JavaScript. But these are all packaged boards, packaged devices. What about in the space where I want to design my own circuit and then have that printed? Do you guys ever do that? And do you have any advice for developers on how to get into that?
Well, I mean, all of the stuff we do is custom built
Yeah.
hardware from ground up. We're one of the few startups in the IoT space that has developed every single line of code and every single board
Yeah.
in-house. We haven't outsourced any of it. We take a lot of pride in that. We're nerds at heart. But to get into that, what I would recommend is either there are two approaches. One is the less painful approach, but it tends to cause the user to be reluctant,
Okay.
not to graduate, which is start from your Arduinos.
Start from an Arduino.
Start there,
Okay.
Start there and move up to something like a Galileo.
Okay.
That requires a little bit more understanding of what's going on. Then go to something that has an embedded development platform, such as the Arduino Une that's just come out. So that has an embedded Linux side to it. So that's kind of nifty, and it requires a little more knowledge of what's going on with the hardware, but it's still an operating system, even though it's a Linux-based operating system. And then I would say there's plenty of tutorials online on how to begin developing a simple board. Right, so now divorce yourself from the software side and look at just how do I build a piece of hardware. You know, a circuit with a timer that blinks some LEDs. There's plenty of tutorials online, because you can't jump straight from the Arduino developing cool stuff that light up drum kit or whatever else, things that are connected to the internet, to let me make that on my own custom board. Because there's just a lot of components on that board that have been abstracted to through APIs. That you never had to worry about the component level.
Right.
So then I'd say start from scratch on the component level side, and say, let me build a very simple circuit.
Okay.
Build it on a breadboard with resistors and LEDs, and get something, you know, to light up, to turn on a fan, whatever else. And then move up from there and look at how to fabricate your own board. There's a lot of free software out there. EagleCAD is a good piece of software that's free. That once you start doing complex things, becomes very painful, and you have to do what we did and splurge on the $7,000 piece of software to design your boards. But up until you get to a certain level of complexity, there's a lot of free software and resources out there.
Okay. Excellent.
So start with EagleCAD, and there's a lot of sample code in there. Start with a breadboard.
So EagleCAD is for designing electronic circuits.
Designing a board. Yeah.
Designing the board.
Yep.
Okay.
Yep. Designing electronic circuits, I'd say start with it, just to wrap your head around the concept, is get a breadboard, a solderless breadboard from Radio Shack or anywhere else. And you can find tutorials for simple circuits that you can set up to understand, you know, what an operating amplifier does, and what a diode actually does, and what an LED does, and building these things in a module away from the component level up.
Yeah. Excellent. Well, hey, that's probably plenty of chat on this topic.
Cool.
It's really nice chatting with you, Ahmed.
Yeah, pleasure was all mine.
It's a cool product.
Thank you. I think so, and that's why I've spent the last year and a half working on it. And you know, I quit my job, my industry job, and decided to be bored to work.
Takes a lot of courage.
Yeah.
And a lot of vision.
Yeah, maybe a little insanity.
Yeah. Good.
Yeah.
Okay. Well, thanks again, and thank you all for
your time.
joining us.
Thanks.
Appreciate it, and I hope you join us next time in CodeChat. Perfect. Yeah, that's good. Good.